I'm going to go over 3 examples of how to solve for different sides and angles in our triangle using the ratios that we set up last class. So that's why it was important that we really understood how the ratios worked, how you set them up properly. So I'm hoping you guys all checked your answers and are feeling confident in that. So when we're using SOHCAHTOA, we have the ability to solve for any piece of information as long as we have 2 other pieces of information. So a side and a side, and you can find an angle, or an angle and a side, and you can find the other side. So when we're looking at this triangle right here, I am given a side and an angle, and I'm looking for my other side here. When I'm looking at this, and I'm looking back at SOHCAHTOA, so this is 2 different ways you can write out SOHCAHTOA here. Either one is fine, it doesn't really matter to me. Personally, I like the second one better because it reminds me which one is on the top and the bottom for my fractions, but it is totally up to you which one you like better. So when I'm looking at SOHCAHTOA and my triangle here, what 2 sides do I have present in this triangle? I have my opposite and my adjacent. So this side right here, is my adjacent, and this side right here is my opposite. So my x is my opposite, and my 12.5 is my adjacent. So which trig function am I using then? SOHCA or TOA? TOA, I'm going to use TOA. So I'm going to write out my formula here. So tan of theta is equal to my opposite over adjacent. And then I can plug in the information that I know. So I'm going to have tan of 38, because that's my angle, is equal to my opposite, which is x, over 12.5. So this is how I'm going to set this up. Now, solving this using algebra, all I want to do is get x by itself. So get x by itself. And so what I'm going to do is I'm going to multiply both sides by 12.5, just like I would in any other math problem. And so I would end up with 12.5 times by tan 38 equals x. And so I can plug that into my calculator just like that. If you have a Casio calculator, so we should have gotten 9.76, okay? 9.76 equals x. And so I can do a quick check here, just based on my drawing, which isn't always super accurate, but it is one way to kind of look and see if you've gotten a decent answer. If this side looks like it would fit, relatively speaking, it's close-ish to the other arm, then you are on the right track. Okay, if you're given units, please don't forget to include units, but I obviously didn't give you units, so you have no units to include. Okay, we're going to do another example of finding a different side here. So in this triangle, I have a T, I have 18, and I have 65. What side is T? Hypotenuse. What side is 18? Adjacent. So I have my hypotenuse and my adjacent. Which trig function am I going to be using? Yes. So cosine of theta equals my adjacent over my hypotenuse. So I'm going to plug in what I know, just like I did last time. Cos of 65 equals my adjacent, which is 18 over t. Now, for you, you might be hard-pressed to see the t just because it's kind of at a weird angle. But my t is in my denominator of my fraction. This means I've got to do a different step in order to solve algebraically here, or solve using algebra. So I'm going to show you how it actually works, and then I'm going to show you the cheater's way to do it. Okay? So Pay attention to what you need to pay attention to understand this. What I'm going to do is multiply both sides by t to get it out of the denominator because I don't like variables in the denominator. And then I would end up with t, cos 65 equals 18. I still need t by itself because I need to solve for my unknown. Yeah. Oh, you can put it in brackets. It doesn't.
Yeah, you can.
Yeah. It's just multiplication, so whatever way makes it clearer for you to understand what's going on. So I still need t by itself because it is a variable. I am trying to solve for it. So in order to get t by itself, right now it's being multiplied to cos 65. So I need to divide both sides by cos 65. So divide by cos 65. Okay, and what that leaves me with is t equals, exactly, 18 divided by cos 65. And this is what you are typing into your calculator. So everyone type it in just to make sure that we're all getting the same answer here. You should have gotten t equals 42.546. Sorry, with rounding. Are we good with that? Can we all get that in our calculators? Perfect. Okay. Now, the cheater's way to do this. So if I am left with cos 65 equals 18 divided by t, what I can really just do, and this is the cheater's way, is just swap my cos 65 and t. So all you need to remember is that when your variable's in the denominator, you're going to switch it with your cos or your tan or your sine. So it would look like t equals cos 65 here, 18 divided by cos 65. Whoops, that was a bad 5. So all you need to remember is that you're switching. What we did here was showing you why you can just switch those two numbers. Okay, so I'm fine if you don't show this step, but I do want you to know that we're actually doing math. We're not just switching things up for the fun of it. Questions? Okay, so we've just learned the two different ways to find a side. Now we're going to go over finding an angle. So I am given two sides here. I'm given my 5 for one leg of my triangle and 4 on another leg of my triangle. And I have theta, which is my unknown angle. So compared to this angle, what two sides do I have? What's my 5? Is that opposite, adjacent, or hypotenuse? Opposite. And my 4 is? Adjacent. So I am, yes, using tangent. So tan of theta equals my opposite over adjacent because it is TOA. So the O is first. Now I'm going to plug in what I know. So tan of theta, I still don't know theta, so I'm just going to put that magic sign back in, is equal to my opposite over adjacent. So 5 over 4. Okay. Now, what I like to do is divide the 5 over 4 first, just so that it's dealt with. So it's going to give us a number and a decimal here. So 5 divided by 4 is 1.25. And so you can write that out. So you would have 1.25 equals tan theta. Now, theta is like our variable. It is acting as our variable in this situation, so I want to get it by itself. In order to do that, I use that second function, or shift tan, which is called our inverse function. So it's tan cosine inverse is what you'll hear me say. So you're going to multiply both sides by tan inverse, which is our tan minus 1. And that gives us theta equals 1.25. Actually, I think we have to put the tan inverse first. Sorry. Tan inverse 1.25. I don't remember if you need the brackets on your calculators. Yes. Multiply.
Just what this is the thing.
Yes, the dot means the multiply. So tan. Oh, I might have messed up.
She did.
Yeah. 1.25. And you don't necessarily need the brackets for this one, depending on your calculator. So theta equals 51.3.
No, it doesn't.
Nope.
It's an angle.
Ah, thank you. 51. Okay, angles you don't usually put decimals in. Sometimes you can put 1 in, sometimes you don't, depending on what your measurement's given. But typically, for our course, angles will be no decimals. Okay, you've learned everything you need to know to succeed in this